Okay, let us see another example. This time we are going to see a proof. So, two uniform rods. Remember here the word uniform, it means that weight is going to occur in the middle. AB and SC of weights, W and length 10 centimeters, are smoothly hinged at A. So this is going to be our A, because that's where these two are hinged. Means that now we are going to be adding AB, so this one is going to be my B. Then I'm going to be adding SC this side, as simple as that. Okay, of course there are weights. So because they are uniform, the weight is going to occur in the middle, so I'm going to assume this is the weight in this side, which I'm going to, they are having the same weight, so this is going to be W. And also this one is going to be having the same weight, W as C. Whenever they give us weight, we don't multiply it by D unless we are given mass. So they have length 10. It means that this way, because they are uniform, this way always divide this rod into 2. So meaning, if this is 10, this is going to be now 5 centimeters. This is going to be 5 centimeters. So that will give us 10 centimeters for that whole part there, even down there. So even this one is going to be 5 centimeters, and also this will be 5 centimeters, the remaining part. Okay, the downstream joins B and C, and the system is kept in a premium in a vertical plane. Okay, so it means that if you have that string, of course you are going to be having tension because it's pulling it to be there. It's pulling these two to be together. It means that we are going to be having tension in that string, and we call this T. And also we are going to be having tension in this string D, as you can see there. As simple as that. Then we continue reading. Another weight of 8, another weight to W climbs a rod SC to a point C, E to a point E such that AE is 8. So to a point E such that AE is 8. So let us call this one our point E. I think that AE is 8. So if from here is already 5, means that from here up to here it's going to be 3. So that AE is 8, meaning from here up to here is also 5. So the balance here will be 2 centimeters. With is. So that's the idea there. Okay. And the angle BSC. So they are giving us this angle. They are giving us this angle as 2 theta. The whole of that. They are giving it as 2 theta. So find in terms of W and C directions at B and C. Okay, so it means that now, because here we're going to be having a reaction at B, then here we shall be with the reaction at C because of the contact. Now, I don't have any angle here, but of course this is 90. What I do, because this is an isosceles triangle, now I'm going to divide this into 2. Dividing this into 2 parts. It means that now this angle here is going to be theta, and then this angle here will be theta. So meaning, you know that when I have angles, if I have these angles, when these two are parallel, if these two are parallel, means the angle here is the same as the angle there. So meaning, if this is theta, you see this angle is theta, but also this one is going to be theta. With the is. So basically, and if also this is theta, then this one is also going to be theta. Now, this weight at AE, they were adding a weight of 2W. AE such that AE is 8 centimeters, but the weight there was 2W. So here you have a weight of 2W, meaning that also this one, remember these are parallel lines, so this one is also going to be theta with the is. Okay, so basically, after doing that, then we start our gymnastics. Okay, reactions at A and B. The first thing I told you, the easiest way is first resolve upwards. So resolving vertically upwards, you see forces going vertically upwards. We have RB plus RC, the ones going up, and also have these ones going down, equaling to W plus W plus 2W. Mean that our R B plus RC is equaling to, this would be 4W, and I call this equation 1. Okay, now to get the value of the reaction, because if you have one of the reactions here, these are weights, so you don't need to multiply by B because these are weights now. So if you want to get one of the reactions, we take moments. Either here, when you take moments here, you shall get the reaction C. You take moments here, you shall get reaction B. So let us take moments at B. So if we take moments at B, now let us take them anti-clockwise in this order. Now, it means that if you take them anti-clockwise, you see this one is going to act anti-clockwise, it's the only force. Now, all the forces coming to B or coming from B, their moments are going to be 0. Why? Because at B, for example, this force R at B, its perpendicular distance from B is going to be 0. Remember, moments are given by the force times the perpendicular distance from the point where you take moments from. So, you see this is also coming here. It means that here, the perpendicular distance from here to this is 0 because this B is a line of action of that. So it's that force is going clockwise, we have this, we have this, we have this. Now in their perpendicular distances. So you see we have this, and you see this is opposite. So to get this, it means that this one is going to be 5. This is opposite. Then 5 sine theta. Okay, if we have that. Now, this one, if you want, it means that this one always divides this into 2 equal parts. So if this is 5 sine theta, it means that also this one is going to be 5 sine theta. The distance from here up to here is always the same from here up to there. And you also see that this one from here up to here is 5, meaning from here up to here is 5 sine theta, and also from here up to here it's going to be 5 sine theta. Now, the question is, how are we going to get this now? You see, based on this angle, this is going to be the opposite. So I'm going to be having this as 2 sine theta. Now, because from here up to here is 5, it means that from here up to here, we will be having now 3 sine theta. That's the idea. Because the distance from here up to here of this weight, this weight was dividing this into 2 equal parts. So this and this is equal to this and this. So when you add this one, you should get that. So when we have all that, the rest are going to be very easy for us. So start with W. We start with our going anti-clockwise. We have only that. So we have now RC times. Remember here, we want the perpendicular distance from here up to here. It means that we are going to be having 5 plus 5 plus 5 plus this. I think this there we are going to get 10. Because from here up to here is 10, and from here up to here is 10. So we are going to say times 10 sine theta equaling 2. Now we have this one from B, so this one is acting clockwise. So the sum of anti-clockwise moments are equal to the sum of clockwise moments. So here we have the force as W, then times this perpendicular distance from A to here is 5 sine theta. Then plus, we have also now this W, then times its perpendicular distance from here now up to here, we add this plus this, which will be 15 sine theta. Then plus 2W times, this is the 2W, I think you see. No, from here, add. So this is going to be 10, 15, 18. So we have 18 sine theta. So basically that's what we have. You see that now our sign is common throughout. So meaning my 10 RC here is going to give me, this is going to be 5W. This is 5W plus 15, that's 20W plus this. I think we are going to get, okay, this is going to be 5W plus 15W, then plus 2 times 18, that's 36 W. And then you see that our RC is going to be, this is going to be 56. So you have there 56 divided by 10, which we can reduce to okay, so when you add this one, we are going to get 56, or we can leave it as 56 over 10 W. So that's our first reaction at C. But remember, we also need the reaction at B. So using from 1, so you say from 1, is that our reaction at A is going to be for W minus the reaction at C, which will be for W, then minus, sorry, let me, okay, sorry, we made a slight error. This is supposed to be 20, not 10. Because when we add this is 10, this and this also 10. So this was 20, that was 20, and so this is going to be over 20. Okay, so okay, let us simplify it by 4. Here we get 14. 14 by 4 here we get 5 W. Okay, so here we shall get then 14 over 5 W. It's going to be 20 minus 14, that will be 6. So our reaction at A is going to be 6 over 5 W. That will be, those are going to be our reactions, but all of them are in newtons. Okay, so after getting that down, we need to get a tension in a string. Now to get a tension in the string, we said to get a tension in the string, you consider, now you separate. So after separation here, we say after separation, that's when you get other forces. You get other forces when you are separating. This one before separation is for only reactions. Then after, if you want other forces, then you separate. Now you see, this one, you can separate either this one or this one, but now you see which one is adding lesser forces. So this one is adding less forces compared to this. So now you separate using this. So now to separate this, we are going to be having, this is going to be the case that we are going to be with if we separate. So here I have my weight, of course I have my weight here, is acting in the middle. So here I'm going to be having my W. So I have this angle and theta. So I have my tension in that order. This is my point B. I have reaction here at C, at B. Reaction at B. This is my 5 centimeters. Then this is now our point A. But here at point A, we are going to be having a reaction. So which we are going to resolve into the horizontal and then the vertical component, which we can call Rx, and then we can call this one Ry. Basically, that's what we have in simple terms. I think you can see if I'm copying this triangle here, this one here, you can able be like they're competing. So that's now what I have after separating. So now, to get the tension, now you resolve. First of all, you can resolve horizontally. To resolve horizontally, you see that force is going horizontally. We have our T equaling 2. Remember, this is now in equilibrium. It means that horizontal forces are equaling to going, the other forces going their side. So this horizontal force should be balanced with this one, means this is equaling to that Rx. Okay, so now I also resolve vertically upwards. Vertically upwards, I have this RB to be equaling to this going downwards. W plus Ry. This is my equation 1, then this is my equation 2. Now from there, after doing that now, it means that now our Rx, this one is now the reaction, because our reaction is going to be this side. That's how our reaction is going to occur. our reaction is going to be there. Or some people will use x here and then they use y there. It's okay. Okay, now from here, now we take moments at B. So taking moments at B, taking moments at B. So now, if we are taking moments at B, in that order, now you see moments at B, we are taking them anti-clockwise. I think you see anti-clockwise. We are going to be having only Rx times the perpendicular distance from here up to here. I think you can see. If now we have this I with theta, you know that from here up to here is 10. So this means this is going to be, if we use this is going to be 10, then cos, because it's adjacent, cos theta. So this is now going to be our perpendicular distance. I think you see, this is 5 cos theta. So the distance from here up here is the perpendicular. Because this is horizontal, this perpendicular distance has to be vertical. So we get Rx is perpendicular distance is going to be now. Sorry? No, this is 10, not 5. This is 10. Not 5. Because from here up to the hypotenuse is 10. This is going to be 10. So I have 10, then cos theta. It's the only force going anti-clockwise. Now we have Ry going clockwise and also W going clockwise. So we are going to get now W times from here up to here. Remember this was 5 sine theta. Because this is opposite goes with the sine and adjacent goes with the cos. So there we have 5 sine theta, then plus we have Ry, then times. Now if we get our Ry there, you see that the perpendicular distance from here up here is the same as from here up here. But remember, we say this is 5 sine theta from here, 5 sine theta. So meaning this is going to be now 10 sine theta. So there you can easily simplify that. I can help you simplify that too. Okay, now you see what we are going to be having here. I think you see that we are going to be having. Now, from here, we have reaction at B. Yes, I think we got our reaction at B. So, no, sorry. This is the reaction at B, not reaction at A. Let us correct that. Let us not make an error. This is the reaction at B, not the reaction at A. This is the reaction at B from here. This is our reaction at B. This is our reaction at B. There. Okay. So we have the reaction at B. So now from here we can easily now remember this reaction here. This 10 is that we have 10 there, we have 5 here, and we also have the 5 here. So you can every divide through by the 10. Okay, where is the line? Okay, so I want you to note now, it's that 5 is common, but now you note that we have our B, we have the W. So you can easily get our Ry from here. So from 2, so that we can simplify at once. So from 2, it's that our Ry is going to be Rb minus W. Our Rb is 6 over 5. W minus W is going to give us W over 5. So this is our horizontal reaction. I mean vertical reaction there. So if we put it here, then we are going to be having R now, X, okay, let me say 10 cos theta equaling 2. This is going to be 5W sine theta, then plus our Ry is going to be now 10, okay, W over 5 minus 10 sine theta. You see this? This is going to give me 2. Is that my 10 Rx cos theta is going to be Now this one is going to be 5W, 2W, so to give me 7W sine theta. And from there, remember I want R. I want this Rx, so I can every divide there, so that now if I divide through my cos, my Rx is going to be 7/10 W. This cos, when divided, I get sine divided by cos, I'll be having tan theta. So this is my Rx. So we have our Ry, we have also our Rx. So what happens? So now, it means that now from here, my tension, so therefore, my tension is going to be, remember our tension is equal to Rx, so it's going to be 7/10 W tan theta. That's the part B. So that is our part B. Then part C, they are telling us that so that the reaction, so they are telling us that so that the reaction at the hinge A is given by now. This is our reaction at the hinge A. Hope you see that from there, our reaction, this is our horizontal, and this is our Y component. So, I think you start my reaction there. So, my reaction is going to be the square root of Rx squared plus Ry squared, which I'm going to ably write as, this is going to be now the square root of, now my Rx, which is going to be 7/10 W tan theta, the whole squared, then plus Ry, which is W/5, the whole squared. So from there, my R is going to be, now we will square this. Look at this, be careful here. When I square this, I get 49 W squared, then tan squared theta. The whole over, when you square 10, you get 10 squared. 100, then plus W squared over 25. That's what we have. Now, and look at our proof here. So now, can I create, I want to create 100 because they are showing the factorize out 100 and the square root was that. So, let me create here times 4 here. Okay, let me create here silent 4. So I'm going to say times 4, times 4. So in simple terms there, I'm creating a silent 1. This is 1. I want to make 100 here so that it's adding the same denominator. So my W, my R is going to be now, here I'm going to be having, I have to start our W, so there I'm having 49 W squared tan squared theta plus 4 W squared, this is over 100, then also this is over 100 now. Now they are having the same LCM. So now I can MDC, I can MD factorize out, which is going to be the square root of. Now, when I factorize out, W squared is common over 100. Now this is going to be times, brackets I'll be remaining with. Remember here, when you look at our proof, here we have 49 times square theta, then plus we are remaining with 4 on the day. So you see the square root of this. So my reaction now is going to be the square root of W squared is W, square root of 100 is 10, then the square root of 49 times square theta plus 4. I think that's the proof they wanted us to handle. So that's what the whole idea of standing in, how do you create a silent, how do you make this 100? Because you see, to get this 10, the denominator was 100 all. So I see what do I need to multiply here to get 100 is 4. Because this is when I cancel and if I have one times this is the same. Anyway, that's it. I wish you well.